were sent into the air in a wicker cage attached to the balloon. When these air travelers returned to Earth safe and sound after a 10-minute trip, plans were initiated to send up human passengers. At first, only criminals were considered. Honest folk, however, were reluctant to let lawbreakers take the glory of being the first humans to fly, and numerous volunteers stepped forward. The performance of the first balloons did not equal the agility of the birds flying around them. The flight of birds inspired the invention of the first airplanes. The question was whether humans could reproduce in a matter of years what evolution had taken thousands of decades to create. To say the least, the first steps in aviation history were uncertain. Still, flying machines evolved very quickly. The humans who rode in them pushed themselves to the limits of their physical endurance. The first rockets showed certain machines could go much farther than airplanes. It was, however, still unclear whether humans would be able to withstand the physical strain produced by these new vehicles. In 1959, NASA began to recruit passengers for their proposed space vehicles. These prospective space travelers had to be in excellent physical condition, under 40 years old, and no taller than 1.5 meters to fit comfortably into the small space capsule. They also had to have university degrees and training as test pilots with more than 1,500 hours of clocked flight time. Over 500 candidates possessing these qualifications were subjected to a barrage of tests to expose the slightest physical, psychological, or intellectual weaknesses. After months of testing and experiments, NASA chose 7 astronauts for its first crew. Then, the real work began. The astronauts started a training program designed to teach them how to withstand the physical strain of flying in space. At the same time, they had to learn every scientific detail essential to carrying out their mission. No stone was left unturned. They had to master everything, from celestial mechanics to space navigation, from the study of rockets and to advanced electronics. There was no question of sending a human into space before it was clear how a living creature would react in this environment. For the first flight, a chimpanzee was put on board. Ham had been trained to carry out several simple operations and served as a guinea pig for the first astronauts. On January 31st, 1961, a Mercury Redstone rocket was prepared for takeoff from Cape Canaveral, with Ham as its passenger. The rocket failed to function, as expected by NASA's engineers. The acceleration was much more violent than anticipated, and Ham was forced to bear a load 17 times his own weight. Because of a defective valve, the pressure inside the capsule dropped violently. After 6 minutes of weightlessness, the capsule fell into the Atlantic Ocean, where it was tossed around for 3 hours before it and its passenger were recovered. The result of the expedition did not reassure NASA about the reliability of its launching system. It did, however, confirm that chimpanzees, and possibly humans, could withstand the severe strain of extraterrestrial travel. Soviet experts greeted the news of the expedition with great interest. They launched several of their own spacecraft with animals on board. The success of the missions reinforced their decision to send a human into space. Several Soviet cosmonauts had already been in training for a number of years. Finally, on April 12th, Yuri Gagarin headed into space.
Говорит Москва. Работают все радиостанции Советского Союза. Московское время 10 часов 2 минуты. Передаем сообщение ТАСС о первом в мире полете человека в космическое пространство. Пилотом-космонавтом космического корабля «Спутника Восток» является гражданин Союза Советских Социалистических Республик, летчик-майор Гагарин Юрий Алексеевич.
he returned to Earth without a scratch after 90 minutes in orbit. Within a month, Alan Shepard took off aboard a ballistic missile. He had to withstand an acceleration pressure 11 times his own weight. The success of his mission once again proved that humans could survive a rocket voyage and bear up under the effects of weightlessness. Other flights followed these first steps into the cosmos. Each new mission was longer than the previous one, and astronauts were soon spending more than a week orbiting the Earth. Some even ventured outside their capsules in simple pressurized suits. Gradually, humans proved they could adapt to conditions in space. They even demonstrated they could endure the hardships of a voyage to the moon. Without doubt, the Apollo lunar missions were the greatest space challenge undertaken by humans. Besides the great strain of takeoff and having to spend long days in a tiny capsule, the lunar explorers had to fly the spacecraft with great accuracy. They needed to have complete control over every operation if they were going to reach the moon. The real challenge began once they landed. The astronauts left their lunar module and ventured out towards unknown dangers. Exposed to showers of falling meteorites and bombarded by cosmic rays, they moved about in a world where they weighed a sixth of their normal weight, and where every fall might prove to be fatal. The aborted Apollo 13 mission was the one that proved the tremendous stamina of American astronauts. Lost in space in a damaged capsule, the three astronauts maintained control and survived, even though they barely had enough air or energy. They never would have survived the disaster, in fact, if they had not been in excellent physical and psychological shape, or if they lacked the required scientific expertise.
Welcome home.
Rather than sending cosmonauts to the moon, the Soviets concentrated on perfecting low-level orbiting around Earth. They launched their first space station, Salyut, in April 1971, and maintained cosmonauts there for longer and longer periods. Salyut stations followed one another into space until early 1986, when the updated Mir was launched. These space stations can accommodate several passengers while they conduct experiments in the hope of better understanding how living organisms adapt to conditions in space. The Americans have a similar laboratory. Skylab was launched in May 1973 by one of the last Saturn V rockets. Like its Soviet counterpart, the American space station was used to analyze human behavior under conditions of weightlessness. Space conditions produce biological difficulties during the first few hours in orbit. It's not uncommon for an astronaut to grow 5 centimeters, since weightlessness expands the backbone. Half of all astronauts suffer from space sickness. Similar to sea or air sickness, it's explained in the same way. The illness is caused by the organism's inability to establish vertical and horizontal points of reference. At the moment, there is no way of predicting which astronaut will suffer from space sickness. There is also no way of countering the sickness or reducing its symptoms. In June 1982, on board the Salyut 7, the French astronaut Jean-Luc Chrétien began a series of experiments to try to understand the causes of space sickness and how an organism might overcome it. His countryman, Patrick Baudry, continued the experiments 3 years later while aboard the American space shuttle. He too used an echocardiographic device to measure the transfer of blood between various areas of the heart. The Canadian astronaut Marc Garneau also carried out experiments related to space sickness during a flight in October 1984. The human organism adapts quite quickly to weightlessness. The symptoms disappear after several days in space. Then, the physiological problems set in. The consequences of long-term excursions in space have been brought to light by the Soviets. Some of their astronauts have spent more than 200 days in space aboard a space station. The circulatory system is the first part of the human body to be affected after several days of weightlessness. Since there is no gravity, there is nothing to draw the blood to the legs and lower body. The body tries to counter this by reducing the volume of blood, so inducing anemia. The Soviets tested a simple solution to this problem aboard the Salyut spaceship. Using sealed or airtight pants, they drew blood to the legs by creating a vacuum and so managed to maintain a stable blood supply. Bones face a similar problem. Freed from the pressure they're accustomed to on Earth, they tend to lose calcium and become more fragile. This is especially disturbing since it does not seem to stop after a period of adjustment. It seriously limits the time a person can remain in space. One solution is to subject the skeleton to certain amounts of strain through an exercise like jogging. These exercises also prevent atrophy of the leg muscles, which are virtually inactive in space. Soviet cosmonauts have developed a complete training program which enables them to stay in space for long periods while limiting the negative repercussions of these excursions. Spacelab has also helped advance physiological research on the effects of space by transforming the cargo bay of the shuttle into a large laboratory. During the first Spacelab mission in November of 1983, astronaut researchers performed experiments on how to deal with weightlessness. Hundreds of biological space experiments have been conducted since Yuri Gagarin's historic flight in 1961. These experiments have defined the dangers to which humans are exposed when venturing outside our biosphere. Today, space travelers can stay aboard vehicles and lead a much more normal life than the original astronauts. They can even take showers, which is far from simple when there's no gravity. And they no longer have to live on pills or dehydrated foods. Their food is regular, and they eat in a normal fashion. As for sleeping, they can sleep anytime, since night falls every 45 minutes. Finally, astronauts can choose whether they sleep horizontally or vertically, as they like. What they really need is a space station which would rotate on its axis and create a centrifugal force or artificial gravity. Although difficult to imagine, even at the beginning of the next century, such a station would provide similar living conditions to those on Earth. By creating a new artificial biosphere, humans may finally be able to break away from Mother Earth.